We're just continuing. We started the topic of DC machines. We did the introduction part of it, whereby we define what is a DC generator. We classified. We looked at the classification of DC generators and their types. And now today we are looking at the calculations involving DC machines. So by the end of the session, you should be able to perform calculations involving DC machines. And we shall start with our calculation or example number one. It says an 8-pole wave connected armature has 100 conductors and is driven at 1200 revolutions per minute. If the flux per pole is 50 milliwebers, determine the generated EMF. Solution. In our scenario, we have 8 poles. We have been told it is an 8 pole. It is a wave wound connected armature. It has 100 conductors and it is driven at a speed of 1200 revolutions per minute. And the flux Weber or the flux per pole is 50 milliwebers. So we are supposed to look for E, and we shall let our formula, we shall let Z to be the number of conductors, then flux to be given by this symbol here, phi, and number of pairs to be let to be P, and the armature speed or the speed of the armature to be N, and then C will be the number of parallel paths through the winding of the conductor. So in that case, it is 8 poles. So it means it has 4 pairs, the speed we have given. And we know that the formula for calculating EMF is given by 2Pn phi Z all divided by C. This is the formula for calculating EMF generated, whereby it is given by 2Pn phi Z, all of these divided by C. So we shall have E will be given by 2 into 4 into 50 milliwebers times 1200 revolutions per minute. So we shall change this into seconds. We shall divide by 60 because 1 minute is given by is equal to 60 seconds. And also we shall multiply by the Z, which is the number of conductors. Then because it is a wave winding, we know that C is equals to P if to 2, sorry. If it could be lap winding, then C would have been equal to 2P. We shall see that in our next example. So if you take your calculator and key in all this, then divide by 2, we shall have 400 volts. Our EMF generated will be equal to 400 volts. You can work with me as I teach. You can take your calculator and work with me. Let's look at example 2. At your own time, you can, or as I teach, you can pause the video and try to solve and see whether you have the same answer as mine. Example number 2, it tells us that a 4-pole generator has a lap wound machine or a lap wound armature with 50 slots with 16 conductors per slot. The useful flux per pole is 30 milliwebers. Determine the speed at which the machine must be driven to generate an EMF of 240 volts. In this case, the question is asking for what? The speed. So our unknown here will be value n. And we know that the formula for getting EMF is given by 2p n phi z, where we've seen that z is the number of conductors, phi is the flux, n is the speed, p is a number of pair of poles, then 2. Then all of this divided by c. And c is we for our case we have a lap wound. So c for lap wound is given by 2p. Is that clear? So let's look at the solution for that. Let's look at solution for that. So E will be given by, uh, the formula is 2p n phi z divided by C. And we have said that for this case is a lap bond, then C will be equal to 2p. So this is our formula. 2p and 2p will cancel. Then we shall be remaining with n phi z. That is speed, flux, and conductors or conductor. So E will be equal to n phi z, and our E is equals to 240 volts. Then n is unknown, that is what we are looking for. Then we have the flux and conductors. So we make n the subject of the formula. So we shall have n is equals to E over phi z. So n will be equal to 240 all over 30 milliwebers times 800. And if you do your calculation, you shall get that n will be equal to 10 revolutions per second or 600 revolutions per minute. Why 600? We know that 1 minute is equivalent to 60 seconds. So you take, what about 10 seconds? We shall have 600 revolutions per minute. We have an example or a work for you to do to calculate. The question says that an 8-pole lap wound armature has 1200 conductors and flux per pole is 0.03 Weber. Determine an EMF generated when running at a speed of 500 revolutions per minute and the generated EMF in the armature if the armature is wave wound. Remember, when working with the lap wound, we know that C is equal to 2p. And when working with the wave wound, we know that C is equals to 2. Kindly remember the formula and try to work on that calculations over there. And if you work on section A and B, these are the correct answers. If you get these answers in your calculation, know that you have done the right thing. That is the right answer for that question. So in my teaching, I normally like to have learner centered, whereby you at least learner participate in my teaching. That's why we can see that we have exercise in between, and this will enable you to understand even more better than just watching what the teacher is teaching without you participating. So work on that assignment at your free time. Let's continue. Example 3. A 6-pole generator has a lap wound armature with, this is supposed to be 2 words, not armature with. This is 2 words, supposed to be 2 words, not 1 word. A 6-pole generator has a lap wound armature with 40 slots with 20 conductors per slot. The flux per pole is 25 milliweber. Calculate the speed at which the machine must be driven to generate an EMF of 300 volts. This example is almost similar to example number 2. This is more of the same as example number 2. If you have understood what is happening in example number 2, it will be very easy for you also to understand example number 3. Example number 3 is more of the same. Example number 2 was asking about what? Was asking about speed. And also in example number 3 is also asking for what? For speed. Sorry for that. So let's look at this. Let's calculate. So n is unknown, speed is unknown, that is what we are looking for. Then 5 we have been given as 25 milliwebers, and Z, that is the number of conductors we have been told is 40 slots. The armature has 40 slots with 20 conductors per slot. That means that we shall have 40 multiplied by 20 to get the total number of conductors in that armature. Then the question says that it is a lap wound. It is a lap wound. Then we know that for the case of a lap wound, C is given by, or C is equals to 2P. The EMF already is given is 300. So let's look at speed. So remember our formula, we know that the EMF generated is given by 2P N phi Z, all of these divided by C. But for this case, we are looking for what? For N. We have said that 2P and 2P will cancel. Therefore, E will be given by N over phi. Then N is the unknown here. We make N the subject of the formula. How? We divide both sides by phi Z and this side also by phi Z. Phi Z on this side will cancel with the other one. So we shall have N will be equal to E over phi Z. And our E is equals to 300. This is E. All of these divided by phi Z. And phi is equals to 25 times 10 raised to negative 3 because it's 25 milliweber. And Z, we have seen it's 800, whereby we have multiplied uh, 40 times 20 to get 800. Okay, so N will be given by all of this, that is 300 divided by all of this. And N, if you perform this calculation in your calculator, we shall see that N is equals to 15 revolutions per second, or 900 revolutions per minute. Is that clear? Let me repeat. N in this case is speed. That is what we are looking for. Therefore, for us to get speed, we have to make N the subject of the formula after getting N phi Z, that E is equals to N phi Z. So when you make the N the subject of the formula from that formula, we shall say that N will be given or will be equal to E, that is the generated EMF, divided by the phi, that is flux, multiplied by Z, conductors. Sawa sawa. And when you divide this, that is 300 divided by 25 times 10 raised to negative 3 times 800, we shall get our N as 15 revolutions per second. You can give your answer in seconds or in minutes. But remember, the answer should be, you should be very keen while converting. So if you're very comfortable to give in seconds, that very clear and simple, because you don't need to convert by multiplying to 60 by 60. Thank you. Let's move to the second part. The second part, we shall leave an assignment. I've stated very clearly that in my class, you have to do work, because it's by this doing you'll be able to learn more. You'll be able, at least as you participate in doing more examples or more assignments, I believe that you will be able to capture more. So in my class, there must be assignments at each and every section. So we have an assignment for you, and the assignment says a 16 pole generator has a lap wound armature with 50 40 slots with 50 conductors per slot. The flux per pole is 5 milliweber and 5 milliweber, sorry. Calculate the speed at which the machine must be driven to generate an EMF of 230 volts. If you check this example and example number 3, this assignment with example number 3 is more of the same. I've just changed the values. So if you are comfortable, it's very clear for you that you'll be able to perform that example or that assignment. What about example number 2 or assignment number 2, sorry? Exercise 2. An 8-pole wave-wound connected armature has 500 conductors and it's driven at 1680 revolutions per minute. If the flux per pole is 2.5 milliweber, determine the generated EMF. In this case, we are looking for EMF, but in the other case, in the first case, we were looking for speed. The first question says you look for speed, and we know that N will be equal to E divided by phi Z. And for this one, this is we are looking for what? EMF. EMF will be given by 2 P N phi Z divided by C. And for this case, C is wave wound. So C will be equal to 2. Remember, for the other one, C will be equal to 2P. So take your time and look at that assignment. May God bless you. That is the end of my presentation for this class. May God bless you. See you in the next video.